This is going to be a relatively short video, just going over pH. So living systems, living organisms are actually really sensitive to pH, or acidic and basic conditions. And so we're going to talk about what pH is and what some of the different things, different items are at different pHs. So what determines pH? It has to do with ions. So we saw ions in previous videos. Specifically what we're looking at here are these two ions down here. They are the ions that come from water. So pure water has equal amounts of these two ions. So our ions are hydrogen ions, so just hydrogen, H+. So that means it's donated its electron. So it's basically a proton running around. And then you've got a hydroxide molecule or hydroxide ion. It is the one that's going to accept the electron from the hydrogen ion. That makes it negative. So you've got hydroxide ions that are negative, and you've got hydrogen ions or protons that are positive. And the combination of these two and the amount of these two is what determines what the pH is. Now you see there, pure water. So water that has nothing else in it is going to have equal amounts of hydrogen and hydroxide ions. So equal amounts of the protons, the H+, and the hydroxide ions, these guys with the negative charge. And that's because these guys pop apart and pop back together. And so they become water, and then they'll pop apart and become these ions, and then go back to water. So what is pH? pH is looking at the amount of these hydrogen ions, the H+, in a solution. So it basically is measuring the amount of acidity. So how many of these little H pluses are in any sort of solution. So if something has a low pH, it's going to be an acid. If something is a high pH, it's going to be a base. So anything, we're going to see the pH scale here in a second. You might be familiar with pH of 7 being neutral. So a 7, grab my little pen. So 7 is the neutral. I think by now I'd be better at writing. So that's neutral. Or this is also what that pure water is when it's going back and forth between the ions and the water. All right. Acids are going to be anything below 7 because they're going to have a lot or more of the hydrogen ions. Bases are going to have a pH above 7 because they're going to have fewer hydrogen ions. And so we'll see this when I show you the pH scale on the next slide. Okay. So before I go to the next slide, what I'd like you to do is tell me what are some things that you know that are acids. You know, things that you're familiar with that are acids or contain acid. And then what are some things that you know that are bases? So things that are what you might know as alkaline. Alkaline is another name for a base. So let's take a look at our pH scale. So there's 7. Like I said, 7 is water, that's neutral. So acids, these guys are anything below 7. So you can see, like I said, they have lots of hydrogen ions. So those are the little white dots. So those are the hydrogen ions. You can see some water and you see a hydroxide ion, but mostly what we've got here are the hydrogen ions. These hydrogen ions are very reactive. They're just protons, so they're going to be wanting to react with things to be able to make bonds. And so this is why things that are acidic are going to be corrosive. So think about strong acids. So think about like battery acid. Battery acid is down in this area. Strong hydrochloric acid, if you've heard of it, it's down in this area. It's very corrosive to our own cells, but also to things like metals because of those hydrogen ions reacting with those materials. You can see we actually have something that's fairly acidic. Your stomach acid is at a pH of 2. That is actually the lowest pH that you find in the human body. And all of our other fluids are actually closer to neutral, with things like blood being just above neutral. You'll find a few things a little acidic, and things that are acidic are going to taste sour because of those hydrogen ions. So you can see some other examples of acids. You may have come up with other ones, but things like coffee, beer, soda. You probably have said something like lemon juice or some sort of other citrus because those contain citric acid. So lots of different acids. Bases go the other way, like we said. So bases have a pH higher than 7. And like I said, few hydrogen ions, so very few, but lots of hydroxide ions. So all of these are hydroxide ions with just a couple of water molecules. And the thing is that with hydroxide ions, they are going to bind with hydrogen ions and neutralize an acid. So very often we're going to use bases as a neutralizer to react with an acid, or we're going to use them as a household cleaner because those hydroxides will react with other materials as well to bind material. So if you look here, things like ammonia and bleach, that's why we use these. These guys are going to feel slippery. They feel slippery because they're interacting with materials on your hands, things like fats and so forth, and creating that slippery feel. Baking soda, milk of magnesia, those sorts of materials are all in this pH of around 9. These are the guys that we take as antacids. Antacid, because they help neutralize acid. So this is why when you have a stomach ache, you often take one of these guys. You can take a spoonful of baking soda. It will do the same thing because it's going to have those hydroxides react with the hydrogen ions and change that pH, make it less acidic. So that is pH. Thing is that, like I said, living organisms, very sensitive to it. So we can't really have like our blood pH go way out of range. Our bodies actually have systems to be able to keep our pH in a very, very narrow range. And this has to do with molecules like our proteins that we'll talk in later lectures about, because that pH will actually undo the molecules, make them not in their correct shapes. They won't be able to do their jobs. So that is pH.